uh, first order spectra in proton NMR spectroscopy. So in the before class already I told the first example AX type of spectrum, and this is the second example, that is AX2 type of spectrum or AX2 type spectrum. So in this type spectrum, so A is one type of protons and X is the another type of proton. For this type of spectrum, the example is 1,1 2 trichloroethane. So here in this ethane molecule, so completely 3 hydrogens are present, and at first carbon atom 1 hydrogen, and at second carbon atom 2 hydrogens are present. Okay, so here 1 hydrogen attached with first carbon atom, and so the connectivity is different. That's why here in this molecule completely 2 different type of protons are present. So 2 different type of protons. So here 2 different type of protons are non-equivalent protons. So here these 2 types of protons are non-equivalent protons. Okay, so for the non-equivalent protons, number of non-equivalent protons equal to number of signals, right? So in this A type of proton is this one, and X type of protons are these. So here in this molecule, so A type of proton only 1 proton is present, and X type of protons are two protons are there. That's why here the name of this spectrum is AX2. So means what, X type of protons are how many? 2 protons are present. So completely the spectrum of this molecule is AX2 type of spectrum, and this molecule gives 2 signals in the spectrum. So here in this 2 non-equivalent protons are giving 2 signals in the spectrum, right? But the 2 signals are undergoes coupling, and gives different type of peaks in the signals according to again n+1 rule. So it is multiplicity or splitting of signals. So here the 2 signals again split into so number of peaks according to n+1. So here n is equal to number of neighboring protons. Okay, so let us see multiplicity in this molecule. Okay, for example, let us see in the first type of proton, that is A type of proton is there, and here it is a reference type of proton, and numbering neighboring protons are 2 for this first A type of protons. So here the numbering neighboring protons are how many? 2 neighboring protons are present for the A type. So A type of protons, so for this A type of proton, numbering neighboring protons are 2, and here in this rule 2 plus 1 equals 3. So 2 plus 1 equals 3. So 2 means what? Number of neighboring protons. For the A type of proton, the adjacent protons are 2. That's why here n is equal to 2, and 2 plus 1 equals 3. So means what? 3 lines are appeared in one signal. So that is A type of proton signal, and that is the triplet. That is triplet. Okay. So next, X type of protons are present. So here X type of protons are 2 protons are present. For this X type of protons, the splitting or multiplicity is, so here it is a reference proton, and the adjacent proton only 1 proton is present. So for this X type of protons, so number of neighboring protons only 1. So for this X type of proton, numbering neighboring protons are only 1 proton, and according to n+1 rule, here n1 plus 1 equals 2. So gives, that is doublet. Gives doublet for X type of proton. So gives 2 signals. So one signal splitting into triplet, and another signal splitting into doublet. Okay, let us see in this spectrum. So one is the triplet, another one is the doublet. So here the triplet is the highest chemical shift value, and doublet is the lowest chemical shift value. So here is a TMS, and so here the lower values to higher value chemical shift values are there. So one is the triplet, another one is the doublet. So triplet for A type of protons, triplet for A type of protons, and doublet for X type of protons. So here this spectrum is like AX2 type of spectrum, and this spectra is the first order spectra in proton NMR spectroscopy, and it is simple spectra, and the chemical shift distance is, the magnetically chemical shift distance is very high, and that's why this spectrum is simple spectrum. So next example, so A to X, for A to X type of spectrum, the example is 1, 2, 3, 3 pentachloropropane. So completely 5 coins are present, that is why pentachloropropane is there. For in this example, so completely 3 carbons are present, that is the first carbon and second carbon, third carbon. So here the first carbon with 2 chlorine atoms and third carbon with 2 chlorine atoms, second carbon only 1 carbon atom is present, and so looks like the first and third carbon atoms, the connectivity, so symmetrically these are same. So first carbon and second carbon. So first carbon with 1 hydrogen, third carbon with 1 hydrogen, and the connectivity difference at second carbon is completely different. That's why in this molecule again, so 2 different non-equivalent protons are present. So completely 2 non-equivalent protons are present. That's why here this molecule gives also 2 signals in the spectrum, and here this is one type of proton. So let us assume like A type of proton, and here this is also one type of proton, that is A type of proton. Looks like the same structure. Okay, this is also A type of proton and this is also A type of proton. And next, so in the at middle carbon 1 hydrogen is there, that is the X type of proton. So A type of protons are 2 and X type of proton only 1. That's why this so example for A to X type of spectrum. And in this molecule, so gives for how many signals? 2 signals. So for this 2 signals also, so 2 signals are going into what again? Splitting. So splitting of signals according to n plus 1 rule, right? So here for this A type of proton, so A type of proton we considered only, so this one or maybe this one, due to same type of protons are there, right? So for example, this is one proton at first carbon and adjacent proton only one proton is present. So how many adjacent protons? Only one adjacent proton or neighboring proton, right? So neighboring proton only one for A type of proton. For A type of proton, multiplicity is what? 1 plus 1 equals 2. 2 means what? That is doublet. Okay, so gives for A type of protons doublet in the proton NMR spectrum. Okay, so in this second X type of proton, for this X type of proton, so only one proton is there, but at X type of protons, 2 adjacent carbons having 2 protons. 2 adjacent carbons having 2 protons. So we considered how many adjacent protons? 2 adjacent protons for X type of protons. So for X type of protons, so adjacent protons are 2, and according to n plus 1 rule, 2 plus 1 again, so 3, so gives triplet in the spectrum. So one triplet and one doublet in the spectrum. Okay, so here in this spectrum of proton NMR, so the chemical shift value, so lower to higher value, one is the triplet and the other one is the doublet. So triplet for X type of protons and doublet for A type of proton. And doublet is 1:1% and triplet is 1:2%, 2:1. So it is the intensity ratio of the peaks. Okay, so next fourth example is a AX3 type of spectrum. So AX3 means A type of proton and X type of protons are 3. So for this, so example is 1,1 dibromoethane. So the name of this compound is 1,1 dibromoethane. So here in this molecule also completely 2 types of protons are present. So two non-equivalent types of protons are present. So one is here, and again another type of protons are at this carbon. For example, this is the first carbon and it is a second carbon. So here AX3, right? So A means only single proton, X means 3 different, means this. Okay, so here it is A type of proton and these protons are X type of protons. So X type of protons are how many? 3 protons are. That's why the spectrum is AX3. Okay, so A is only 1, X is 3 protons. So gives again how many signals? 2 signals. So 2 signals in the proton NMR spectrum. Okay, so for this molecule, so again the multiplicity according to n plus 1 rule for the A type of protons. So for A type of protons, so adjacent protons. So for A type of protons, so neighboring protons or adjacent protons are 3. Okay, so then 3 plus 1 equals to 4. So 4 means it gives coordinate. Gives coordinate for A type of protons. Okay, so next the splitting for the X type of protons. Splitting for X type of protons. So for this X type of protons only having one adjacent proton. Only one proton is present, that is the adjacent proton or neighboring proton. Only one. So 1 plus 1 equals to 2, that is the doublet. So for this spectrum, so 2 signals are appeared in the spectrum. So here the 2 signals multiplicity or splitting is for one coordinate and the one is the doublet. So in the spectrum, so chemical shift value coordinate is the higher than doublet due to the coordinate signal for A type and A type of carbon having 2 most electronegative atoms. That's why the highest chemical shift value for coordinate and then doublet. And this is the coordinate signal and it is a doublet signal. Coordinate signal for A type of protons and doublet signal for X type of protons. And it is so 1:3:3:1 ratio of intensity and for the doublet 1:1 ratio of intensity. Example is A2X3 spectrum. So A2 means one type of proton. So X is the another type of proton, but one type of protons are 2, another type of protons are 3. So for this spectrum, so one example is there, that is the ethyl bromide or bromo ethyl. So in this, so 2 hydrogens at one carbon atom, 3 hydrogens at another carbon atom. So 2 hydrogens at one carbon atom. So we'll take like A2 type. Means what? How many hydrogens are there? 2 hydrogens, one type, that is A type of proton. So next type. So another type of protons are also there. Here 3 protons are present. So they are X type of protons. So X type of protons and A types of protons. A types of protons are 2, X type of protons are 3. Completely. So in this molecule, 2 types of protons are present. The 2 types of protons gives 2 signals in the spectrum, and the 2 signals again so undergo splitting according to n+1 rule. Okay. So for example, for this molecule, splitting for A type of proton. For A type of proton, so adjacent protons are 3. Adjacent protons are 3 or neighboring protons are 0 for A type. Okay, so neighboring protons. 3 plus 1 equals 4. So 4 means coordinate. Okay, so same. For the X type of protons, so the adjacent protons are, for X type of proton, adjacent protons or neighboring protons are 2. According to n+1 rule again would, so 2 plus 1 equals 3. So gives what? 3. So 2 signals split into, one is the coordinate and the one is the triplet. So in the spectrum, so here in the chemical shift values difference is very high, and one is the coordinate and another one is the triplet. So coordinate for which type of protons? A type of protons. So how many A type of protons are there? 2 protons. Okay, and triplet for X type of protons. And how many X type of protons are there? 3 protons. So that is CH3. So completely A2 and X3. So here A2 and A means A type of proton gives coordinate, and so X type of proton gives triplet. One coordinate and one triplet appeared in the spectrum. So hence the spectrum is a A2X3 type of spectrum. And the example is bromo ethyl. Last example for the first order spectrum is AMX type of spectrum. So here AMX means completely 3 different type of protons present, and the 3 different type of protons gives like this AMX type of spectrum. So usually this AMX type of spectrum gives only unsaturated compounds. That's why here I taken one example, that is the vinyl acetate. This compound name is vinyl acetate molecule. So vinyl acetate molecule gives AMX type of spectrum, and here this molecule again I written like this. So here the C double bond C, and here two hydrogens are here one hydrogen. So two hydrogens at first carbon atom and another hydrogen at a second carbon atom. So here usually these two hydrogens are looks like the same, but here in this molecule completely different type of protons. So like it is a type of proton, and it is M type of proton, and it is X type of proton, like this AMX. Due to, so it is an unsaturated molecule, and this proton is cis 2 acetate molecule. So this proton is trans 2 acetate molecule, and this proton is cis 2 acetate molecule. So that's why these are chemically different, magnetically different protons. Okay, so for this molecule, so gives what, how many signals in the spectrum? Again 3 signals in the spectrum, but for this molecule coupling is completely different. For example, coupling according to n+1 rule. So for this A type of proton, like HA, so HA having HM type of adjacent proton and HX type of adjacent proton. HM type of adjacent proton, only one proton is there, so giving doublet according to n+1 rule. So it is HM. So HA according to HM gives doublet. Okay, so gives what? Doublet. And same HA proton according to HX also gives again doublet. HX also gives again doublet. Okay, so HA gives doublet according to n+1 rule. So for HM and for HX. So one doublet for HM, one doublet for HX according to n+1 rule. 1 + 1 is a doublet for HM, 1 + 1 is doublet for HX. So completely how many lines? 4 lines. 1, 2, 3, 4. Okay, so 4 lines for only HA type of protons. How many lines? 4 lines. Okay, so 4 lines are appeared in the spectrum for HA type of protons. Okay, same like HM type of protons. If we take HM type of proton, so HM type of proton gives one doublet for adjacent HA type of protons. Okay, and another doublet for HX type of proton. Another doublet for HX type of proton. HX is a HX type. So one doublet for HA, one doublet for HX. So completely 1, 2, and here 1, 2. Completely 4 lines. So 1, 2, 3, 4. So 4 lines. So these are 4 lines. 4 lines for HA, 4 lines for HA. So similarly for HX, for HX also gives completely 4 lines for according to HA and HM. So for HA 4 lines are appeared, for HM 4 lines, and for HX also 4 lines. Completely this AMX spectrum gives 12 lines in the proton NMR spectrum. So like here the TMS, so completely how many lines? So like first one 4 lines, and here also 4 lines for HX, HM and HA type. So completely how many lines? 12 lines. So 12 lines are appeared in the spectrum for AMX type of spectrum. So it is small different due to coupling is completely different.